Well, hello. Welcome to another video for mathematics. In this video, we're going to be discussing recursive sequences. So we're dealing with sequences, series and sequences, and I've got an example here to show you as to how a recursive sequence works. So here I have a given. I have a sub 1 equals 2. So the point of this is that I want to find the first 5 terms of this sequence. And I'm being given the value of the first term, a sub 1. So that sub 1 refers to the number value that it is, or the first value. And this is the general equation that we're going to be working with. So here it says a sub n, remember n represents the actual value, equals negative a sub n minus 1 times n plus 1 divided by n. So again, I'm given the value of a sub 1, which equals 2, and I want to find the value of the first 5 terms. So now I want to find the value of the second term, a sub 2. a sub 2 equals, so now recall, if I go back to my original equation, you'll see that it's a sub n. Whatever value I have for n, I need to place that value on all of my n's on my general equation. So in blue I have a sub 2, which refers to the second value. So then I look on the right side of my general equation. Now what that means now is that every n that I see in that equation I need to replace now with 2. So I'm going to replace it. I'm going to replace each n one by one so you can see how I do it. So I had negative a sub 2 minus 1 is a sub 1, and I already know the value of a sub 1, which is 2, so I can go ahead and replace it. And recall that I have that negative sign there in front, so that's going to actually be negative 2. And then I have 2 more n's on the other grouping symbol, so I need to replace those with 2 also. And now this is just simple algebra. Okay, so I have 2 plus 1 is 3 divided by 2, and to simplify this, I can just cancel out my 2's, leaving me with negative 3. And that's the value of a sub 2. Now, keep in mind that in order to find a sub 2, I needed to know the value of a sub 1. So I need to know the value of the previous term in order to find the value of my next term. And hence that's where the term recursive sequence comes in. So now I'm looking for the value of the third term. So recall now that I have to replace every n with a 3. So let me go back so you can see how that works. Okay, so again, now I can do a negative a sub 2, and I know the value of a sub 2, which is negative 3. 2 negatives make a positive. And again, I'm just continuing on with my simple algebra here. I'm going to cancel out my 3's, leaving me with 4. Okay, so you notice that there's sort of a pattern that's kind of building. You have 2, negative 3, 4. Now there's not a ratio that's being formed here, so this is not going to be a geometric sequence. So I'm looking for the fourth term, and again I'm finding it the same way I did the others. 4 minus 1 is a sub 3. I know the value of a sub 3 is 4, so that's negative 4. 5 over 4, cancel out my 4's, giving me negative 5. That's the value of a sub 4. And now a sub 5, same thing. So hopefully you kind of catch the pattern as to how you solve for sequences and you find the terms. Okay, I know the value of a sub 4 is negative 5. Negative and negative makes a positive. Cancel out my 5's, I'm left with 6. So let's look for a pattern. Was there a pattern? Was there a common difference from a sub 1 to 2 to 3 to 4 to 5? So if I go to a sub 1 to a sub 2, the difference is 5. Negative 5 actually, because it's from 2 to negative 3. But then from 2 to 4, the difference is 7. And then 9, and then 11. So there's no common difference, so it's not an arithmetic sequence. And there wasn't a common ratio either, so it's actually neither a geometric nor an arithmetic sequence. Okay. So again, as I evaluate each one of these terms, I don't find any pattern that would tell me that it's either one of these types of sequences. I'll have other videos that will show you either a geometric or arithmetic sequence, but this particular problem doesn't have any pattern like that. So in order to find the value for a sub 4, I needed to know the value of a sub 3. And likewise, again, every term that I found, I needed to know the value of the previous term. And that's where recursive comes into play. Okay, well, that does it for this video where recursive sequences. I just gave you an example as to how to work one out. I hope this helps, and good luck in your studying.